This is a Michelson Interferometer. A beam of light here sends light that hits a beam splitter, with half of the beam coming this way, being reflected by this mirror and coming back to the beam splitter. The other half comes this way, hits this mirror, and is reflected back. When they both hit that half mirror, part of that beam then goes in this direction, with those two beams marching next to each other and hitting a target, or we can watch it through this window down here. Now, if the two beams travel the same length, then they will be in phase when they come out from the half-silvered mirror there. But if they're out of phase, in other words, if they've traveled a difference in path that is a half-integer multiple of the wavelength, like 1/2 wavelength, 3 halves, 5 halves, etc., then they'll be out of phase and they'll be dark. What we see here is a dark stripe in the pattern. See the green down there? This is a mercury lamp that's emitting a very green monochromatic signal. And so we have here, if I change the orientation of this mirror back here by tilting it, you can see that I get a variety of pinstripes there. And if I tilt it back, I can try to reach the center of the bullseye. I should get something that's almost circular. Well, that's not so great. But now, if I go to the other adjustment over here, which simply moves this mirror in and out, let's see what happens. I can get this pattern to march across the screen. And every time one of those black lines is replaced by another one, that mirror has traveled about 1/4 of a micron. That means about 1/300th of the width of your hair. The Michelson Interferometer is a very accurate way of measuring very small distances.